H.C. Verma, Chapter 1, Question number 1. A block of mass m 2 kg placed on a long horizontal frictionless table is pulled horizontally by a constant force F. It is found to move 10 meters in first 2 seconds. Find the magnitude of F. Since the initial speed of the block is 0, from Newton's equation of motion, we know that S is equal to half at square, where a is the acceleration of the body and t is the time of motion. Putting the values, we get 10 is equal to half into a into 4, or a is equal to 5 meter per second square. Now from Newton's second law of motion, we know that the force is equal to mass into acceleration. Therefore, force is equal to 2 into 5, that is 10 newtons. This is our answer. In order to request solution to any question from H.C. Verma book, post the question number and chapter number in comments below. Like and share the video to help other students find us. Subscribe the channel for further updates. Thank you for watching. H.C. Verma, Chapter 5, Question number 2. A car moving at 40 km per hour is to be stopped by applying brakes in next 4 meter. If the car weighs 2000 kg, what average force must be applied on it? The initial speed of car U is 40 km per hour, that is 40 into 1000 divided by 60 into 60 meters per second. Simplifying, we get U is equal to 100 by 9 meters per second. From equation of motion, we have V square is equal to U square plus 2AS. Since the car is to stop, its final velocity V is 0. Also, as per the equation, displacement is 4 meters. Putting the values, we get 0 is equal to 100 by 9 whole square plus 2AS, which implies 2 into A into 4 is equal to 100 into 100 divided by 9 into 9, or A is equal to 100 into 100 divided by 81 into 8 meters per second square. The negative sign here implies that the acceleration of the car must be in direction opposite to the direction of motion. Now the force applied is equal to mass into acceleration. Putting the values, we get 2000 into 100 divided by 81 into 8. That is 30,864 newtons, or 3.1 into 10 to the power 4 newtons. This is our answer. In order to request solution to any question from H.C. Verma book, post the question number and chapter number in comments below. Like and share the video to help other students find us. Subscribe the channel for further updates. Thank you for watching. H.C. Verma, Chapter 5, Question number 3. In a TV picture tube, electrons are ejected from the cathode with negative speed and reach a velocity of 5 into 10 to the power 6 meters per second in traveling 1 centimeter. Assuming straight line motion, find the constant force exerted on the electron. From the equation of motion, we have V square is equal to U square plus 2AS. Putting the values, we get 25 into 10 to the power 12 is equal to 0 plus 2 into A into 10 to the power minus 2. Which implies A is equal to 25 by 2 into 10 to the power 14 meter per second square. Now force is mass into acceleration, that is 9.1 into 10 to the power minus 31 into 25 by 2 into 10 to the power 14 newtons. That is 1.1 into 10 to the power minus 15 newtons. This is our answer. In order to request solution to any question from H.C. Verma book, post the chapter number and question number in comments below. Like and share the video to help other students find us. Subscribe the channel for further updates. Thank you for watching. H.C. Verma, Chapter 5, Question number 4. A block of mass 0.2 kg is suspended from the ceiling by a light string. A second block of mass 0.3 kg is suspended from the first block through another string. Find the tensions in the two strings. Let the tension in lower string be T1 and the upper string be T2. Let us draw the free body diagram of the lower block. If we denote its mass by m2, then gravitational force of m2g will act on it in vertically downward direction. Tension T1 will pull the block upward. Since the block is at rest, net force on it must be 0. Therefore, T1 must be equal to m2g. Putting the values of m2 and g, we get T1 is equal to 0.3 into 10, that is 3 newtons. This is our answer. Now let us draw the free body diagram of the other block. If we denote its mass by m1, then gravitational force of magnitude m1g will act on it in downward direction. Tension T2 pulls it upward. Also, the tension in the string joining the two blocks will pull it downward with force T1. Balancing the forces in vertical direction, we get T2 is equal to m1g plus T1. Putting the values, we get T2 is equal to 0.2 into 10 plus 3. That is 5 newtons. This is our answer. In order to request solution to any question from H.C. Verma book, post the question number and chapter number in comments below. Like and share the video to help other students find us. Subscribe the channel for further updates. Thank you for watching. H.C. Verma, Chapter 5, Question number 5. Two blocks of equal mass are tied to each other through a light string. One of the blocks is pulled along the line joining them with a constant force F. Find the tension in the string joining the blocks. Let us first look at this animation to get the proper understanding of the situation. As can be seen, both the blocks move with same acceleration. Let that acceleration be A. If we look at the forces in action, force F is applied to move the blocks and there is tension in the string. Let that tension be T. Tension will pull the block on the right side towards left and the block on the left towards right. The only horizontal force acting on the block on the left is this tension and the block moves because of this tension. Let us now draw the free body diagram of blocks. For the block on the right, the horizontal forces acting on it is F towards right and T towards left. It moves towards right with acceleration A. Thus, F minus T must be equal to ma. For the block on the left, the only horizontal force on it is T towards right and it is also moving with acceleration A. Therefore, T must be equal to ma. Subtracting equation 2 from equation 1, we get F minus 2T is equal to 0, which implies T is equal to F by 2. This is our answer. To request solution of any question from H.C. Verma book, post the question number and chapter number in comments below. Like and share the video to help other students find us. Subscribe the channel for further updates. Thank you for watching. The basic thing that we have to understand in this question is that in a velocity time graph, the acceleration is given by the slope of the graph. So if we have to find force at t is equal to 2 seconds, we need to find the acceleration at t is equal to 2 seconds. The acceleration at t is equal to 2 seconds can be found by finding the slope at t is equal to 2 seconds. As we can see in the graph, the change in velocity in first 3 seconds is 15 meter per second. So the slope of the graph or the acceleration for the first 3 seconds shall be 15 divided by 3, that is 5 meter per second square. So the force is given by mass into acceleration, which is 0.05 kg into 5 meter per second square. So the total force will be 0.25 Newton. At t is equal to 4 seconds, as we can see in the graph, between 3 and 5 seconds, the change in velocity is 0. So for this duration of 2 seconds between 3 and 5, the acceleration is 0 and hence the force will be 0. In order to find the slope for t is equal to 6 seconds, we need to find the change in velocity in the 3 second duration from 5 seconds to 8 seconds. The change in velocity during that period is minus 15 meter per second and the time is 3 seconds. Therefore, the acceleration will be minus 15 by 3, that is minus 5 meter per second square. So the force will be mass into acceleration, and which comes to minus 0.25 Newton. The negative sign here indicates that the force will act in opposite direction of the displacement or opposite direction of the motion. To request solution of any particular problem of H.C. Verma, please post the question number and chapter number in the comment section. We will post its solution in a video. Please subscribe the channel for latest updates. Thank you for watching. H.C. Verma, Chapter 5, Question number 7. Two blocks A and B of mass MA and MB respectively are kept in contact on a frictionless table. The experimenter pushes the block A from behind so that the blocks accelerate. If the block A exerts a force F on block B, what is the force exerted by experimenter on A? Let us draw the free body diagram of block B. As is given in the question, block A exerts a force F on B. There is no other horizontal force acting on block B. Block B will accelerate because of this force. Let this acceleration be A. Since net force is equal to mass into acceleration, F must be equal to mb into A, or A is equal to F divided by mb. Now let us draw the free body diagram of block A. The experimenter is pushing the block with some force. Let that force be Fa. Since block A is pushing block B with force F, its reaction will act on block A in backward direction. When block A is pushed, both the blocks will move together. Therefore, the acceleration of block A must be same as the acceleration of block B. Net force in horizontal direction must be equal to its mass into acceleration. Therefore, Fa minus F is equal to ma into A, which implies Fa is equal to ma into A plus F. Putting the value of A, we get Fa is equal to ma into F by mb plus F, or Fa is equal to F into 1 plus ma by mb. This is our answer. In order to request solution to any question from H.C. Verma book, post the question number and chapter number in comments below. Like and share the video to help other students find us. Subscribe the channel for further updates. Thank you for watching.
First, let's calculate the acceleration of the droplets. In the question, it is given that initial speed u is 30 meter per second. Since the water droplets come to rest after collision with head, final speed v is equal to 0. The displacement as per the question is equal to the radius of the water droplet, that is 1 millimeter, which is 0.001 meter. Now we know that v square is equal to u square plus 2as. So putting the value, we get 0 is equal to 900 plus 2a into 0.001. Solving, we get acceleration is equal to minus 450 into 1000, that is minus 4.5 into 10 to the power 5 meter per second square. The negative sign here indicates that the force or the acceleration is opposite to the direction of motion. Now force is equal to mass into acceleration, and mass is 4 milligram, that is 0.004 gram, which is 4 into 10 to the power minus 6 kg, and acceleration as we have seen is 4.5 into 10 to the power 5 meter per second square. Putting the value in the equation, we get F is equal to 4 into 10 to the power minus 6 into 4.5 into 10 to the power 5 Newton, that is 1.8 Newton. For requesting any question from H.C. Verma, post the chapter number and question number in our comment section. Subscribe the channel for latest updates. Thank you for watching.
H.C. Verma, Chapter 5, Question number 9. A particle of mass 0.3 kg is subjected to a force F is equal to minus kx, with k is equal to 50 Newton per meter. What will be the initial acceleration if it is released from a point x is equal to 20 centimeter? Magnitude of net force on the particle is k into x. Since, as per Newton's second law, net force is equal to mass into acceleration, ma is equal to kx. Putting the values, we get 0.3 into a is equal to 15 into 0.2, or a is equal to 10 meter per second square. This is our answer. To request solution to any question from H.C. Verma book, post the question number and chapter number in comments below. Like and share the video to help other students find us. Subscribe the channel for further updates. Thank you for watching. H.C. Verma, Chapter 5, Question number 10. Both the springs shown in the figure are unstressed. If the block is displaced by a distance x and released, what will be the initial acceleration? Let us move the block by distance x towards right. The spring in right is compressed by x, whereas the spring on the left is elongated by x. Now let us draw the free body diagram of the block. Since the spring on the left is elongated by x, it pulls the spring with force of k1x. Also, the spring in right is compressed by x, so it will push the block with force k2 into x. Therefore, the net force on the block is k1x plus k2x, which implies ma is equal to k1x plus k2x, or a is equal to k1x plus k2x divided by m. This is our answer. To request solution to any question from H.C. Verma book, post the question number and chapter number in comments below. Like and share the video to help other students find us. Subscribe the channel for further updates. Thank you for watching.